Welcome everyone. Today we are looking at Unit 8, and specifically we are looking at 8.2, which is graphing rational equations. Now, it is very, very, very similar to what we've been doing for quite a while, to be perfectly honest. Here, let me show you what I mean. Remember this? We've used this exact slide. This is like the 5th time now. Each of these different things, and again, these notes are in your 1.3 notes, like 3.1, and I think 5.2. This slide is everywhere. If you don't have it readily available, I do recommend copying it down again. You don't absolutely have to. But remember, outside is a vertical transformation, inside is horizontal. Multiplication is a stretch or compression. Addition or subtraction is a translation. A negative sign is a reflection. That's really it. There's those 6 transformations. Location and type tells you everything you need to know. So let's take a look at how this specifically relates to rational equations. For example, how is this rational equation transformed from its base equation, from its parent function? Well, we have a vertical stretch. There is multiplication on the outside. What is it stretched by? Yeah. It's stretched by a factor of 5. We have a shift to the left or right. Well, left or right shift means it's horizontal. That means it's inside our symbol. Our symbol in this case is that division sign. So we have x minus 2. That tells us it's shifted by 2 units. And remember, everything on the inside is backwards and stupid, so even though negative suggests that we're moving left, we're actually going to move to the right. Finally, we have a shift either up or down. That tells us that it's going to be vertical, so we look for outside. And if it's a shift, that means addition or subtraction. So on the outside, addition or subtraction, I see a plus 3. Plus means up, so we're going up by 3 units. So it's a vertical stretch by a factor of 5, shifted to the right 2 units, and shifted up 3 units. It's that straightforward and that simple. However, don't forget that if you have multiplication on the inside, so you have a number multiplied by x, that is a horizontal stretch or compression, but the factor is not just the number you see, it's 1 over the number that you see. So if this equation had a 2 next to the x, it wouldn't be a horizontal compression by a factor of 2, it would be a horizontal compression by a factor of 1 over 2, or 1/2. Now, one of the things that we've done a lot is rewriting different equations. We've taken standard form of a quadratic, so ax squared plus bx plus c, and turned that into vertex form. There's going to be several questions about doing that in this unit as well, in this section. So this is mostly standard form for a rational expression. However, it's very difficult to tell just by looking at that what your expression is going to look like. So we have a rule to help us turn that into something that looks like this. This gives us everything that we need. We've got our vertical shift, our vertical stretch, our vertical reflection, our horizontal shift, and our vertical shift. So we know exactly what this graph is going to look like. The way to do this is through synthetic, or if you prefer long division, you can use long division. But I'm going to teach you guys how to do it with synthetic division. So, once again, here's the equation. Synthetic division, you're going to take the top, that's 3x minus 7, and you're going to put that in your box, 3 and negative 7. On the outside, you're going to take the opposite of what's being done on the bottom. So we have x minus 1. That's going to be 1. No, it's the opposite. It's not negative 1. It's just 1. Using our rules for synthetic division, drop the 3. Bring it up. Negative 7 minus 3 is negative 4. And lo and behold, we have our formula, which is a times 1 over x minus h plus k. There's your a, there's your h, and there's your k. So all you have to do is plug those individually in. So instead of writing a, you're going to write negative 4. Instead of writing h, you're going to write 1. And instead of writing k, you're going to write 3. However, that's not the only way that they can give you something and ask you to write a formula. They could give you 2 points on a picture. So they could give you a picture like this, and they could say, please write the formula. Now, if you can't see those 2 points because they're too small, those points are negative 3, 2, and 1, negative 2. Once again, here's our formula. Notice that in blue we have our asymptotes written. The asymptotes intersect. That intersection point is actually the x and y value of our vertex, our h comma k. So h is the x value of the vertical line, so we notice that that crosses at negative 2. K is the y value of the horizontal line. Looks like that one's at negative 1. And a uses this formula. Now I'd like you to take a look at it for a second. What does this formula look like to you? Hopefully, it looks like the slope formula that you guys memorized back in Algebra 1. And that's because that's exactly what it is. That slope formula gives you the a value for a rational equation. Pretty cool, huh? Oh, excuse me. You might not have been able to see the formula. So once again, here it is. y2 minus y1 divided by x2 minus x1. So that's really all there is to it, guys. That's all there is to this section. There are 15 questions. I didn't do the 24 that I did last time because you've only got today and Monday to work on this one. Most of the problems should go relatively quickly as long as you're following along with these notes and how they work. If you have any questions, as always, you guys know where to find me, either through email or in class. But good luck, Wildcats. Let me know if you need anything else.